or the life forms or life forms is called what? Biomolecules. If we have to go by the definition of biomolecules, then the definition of biomolecule is what? A molecule which is a chemical compound, and basically these chemical compounds are found inside a living organism. Then we call that molecule as biomolecule. So definition, exact definition will be like this, which you have to write when it has been asked in exam. A biomolecule is a chemical compound found in living organism. And biomolecules बने किससे किससे होते हैं? Like what are the compounds that made up the biomolecules? They are formed of like carbon, hydrogen. Biomolecules, they are formed of what? Carbon, then hydrogen, then they are formed of oxygen also, sometimes nitrogen, sulfur, phosphorus, many things are there. Okay, so carbon like elements, hydrogen, oxygen, sulfur, nitrogen, phosphorus, all of these compounds sometimes join together with one another, or sometimes they are in the polymerizes form. So all these combine together to form what? They form biomolecules. And basically inside the living organism, what are the main biomolecules which we have to study? Like we have to study carbohydrates, we have to study about the proteins, then nucleic acids, then enzymes are also there, also some vitamins are also there. So these are the biomolecules which we have to basically study. Nucleic acids include what? They include DNA and RNA. And carbohydrate includes what? Monosaccharides, disaccharides, and polysaccharides. And inside this monosaccharide, basically glucose, fructose, then disaccharides or oligosaccharides, basically. So oligosaccharide includes what? They includes maltose, lactose, fructose, and polysaccharides. Polysaccharide includes large chain of these monosaccharides like starch or cellulose. Okay, so one by one we are going to take these like carbohydrate, protein, nucleic acid, enzymes, vitamins, etc. Okay, so here also we can see the definition, which includes like complex organic compounds which govern the common activities of the living organism. They are called as biomolecules. And now what are the carbohydrates? Carbohydrates are basically are the compounds of carbon, hydrogen and oxygen. ये तो मोटा मोटा तौर पे हम लोग यही बोलते हैं कि what is this carbohydrate? Compounds of carbon, hydrogen and oxygen. इसके साथ साथ they are also called as saccharides. अब saccharides क्यों बोलते हैं? Does anyone know why this carbohydrate is also called saccharide?
They're basically sugars, right?
Yeah, they are basically sugars. Means most of the carbohydrate taste sweet. That is why they have been given the name saccharide. Saccharide का itself Greek word से आया है saccharon, जिसका नाम होता है sugar. लेकिन not all the carbohydrates are sweet. Most of them are sweet. That is why the name has given saccharide. Okay, also called as saccharides. Okay, now.
What are monosaccharides?
Yes, monosaccharide is a carbohydrate only. It will come in the classification. Okay, so first. मोनोसैकेराइड्स को शुगर क्यों बोला जाता है? बिकॉज कार्बोहाइड्रेट्स को सैकेराइड्स क्यों बोला जाता है? बिकॉज सैकेराइड्स आर शुगर. सैकेराइड्स आर और means would be more suitable. Saccharide means sugar. That is why they are also called as. That is why also called as. Carbohydrates are also called as. Okay. Carbohydrates are also called as sugar, saccharides. So this one points about carbohydrates. Then they are made up of what? Composed of carbon, then hydrogen, and then oxygen. ये अभी मोटा मोटा definition जो normally लोग बोलते हैं. This is all about carbohydrates. Then most of them have general formula of what? Most of carbohydrates. Can anyone tell what is the general formula? Carbohydrates have what kind of general formula?
C X.
Yes.
To water, right?
Yes.
Yeah.
In the composition of 5. This is followed by most of the carbohydrate, but ये सारे carbohydrates नहीं follow करते हैं. There is an exception, like some of the acid, acetic acid की बात करें. Acetic acid. What is the formula? Okay. CH3COOH. अगर लोग इसको इस फॉर्मूले में सेट करें, then it will get set like this one. देखो C2 हो जाएगा, then H2O2. So this is what? This is acid, but it is also getting fitted into this formula. So this is an exception also. Other than that, ramenose, structurally C6H12O5 is the formula, but it is what? It is a type of carbohydrate only, जो कि ये formula में fit नहीं बैठ रहा है. So we can write that most of the carbohydrate follow the general formula CXH2O whole Y, but not all of them. Okay. Now exact definition, what we have to write in exam. Carbohydrates. They are basically the optically active polyhydroxy aldehydes or ketones, or the compounds which produces such units on hydrolysis. Hydrolysis is called as what? Carbohydrates. अभी तक तुम लोग बोल रहे थे क्या? This carbohydrate is composed of carbon, hydrogen, oxygen. These are saccharides, and they are having the general formula CXH2O whole Y, etc., etc., etc. But this is the proper definition. What is the definition? That these are optically active. Optically active मतलब कि जो plain polarized light को क्या कर दे? Rotate करने के capable हो. तो carbohydrates are capable of rotating the plain polarized light. इसीलिए optically active. Then polyhydroxy aldehyde या ketone. उन लोगों के फॉर्मूले में either they are having the aldehyde in their chemical composition or they are having the ketone in their chemical composition. Then polyhydroxy means they are large in number. Okay, so that is why optically active polyhydroxy aldehyde or ketone. और उसको फर्दर करेंगे तो हाइड्रोलाइसिस पे जो यही एल्डिहाइड या कीटोन के मॉलिक्यूल्स को दे उसको क्या बोलेंगे? कार्बोहाइड्रेट. एनी डाउट टिल हियर अप टू द डेफिनेशन?
No, ma'am. No, ma'am.
Okay. Now they have been classified into monosaccharides, oligosaccharides and polysaccharides. Carbohydrates classify किसमें हुए हैं? Monosaccharides, then oligosaccharides, then polysaccharides. अब monosaccharides क्या होते हैं? The simplest molecules या simplest of the carbohydrates. इतने simple होते हैं कि इनको further और hydrolyze नहीं किया जा सकता. They cannot break into further smaller components or the pieces. Okay, so these are what monosaccharide examples में the most simplest one and famous one, glucose या fructose. Then oligosaccharides are those carbohydrates which yield 2 to 10 units of the carbon chain in them, or 2 to 10 units of the monosaccharides in them. This will be the perfect. On hydrolysis they give what? On hydrolysis they give 2 to 10 units of monosaccharides. उसको हम लोग बोलेंगे क्या? Oligosaccharides. Example के लिए we can write maltose, we can also write sucrose, then fructose. Many times ये भी पूछ लिया जाता है कि what is the hydrolysis component of maltose? Then maltose is formed of glucose and glucose. Whenever maltose will break down, it will give glucose and glucose. Same way, sucrose, whenever it will break down, it will give glucose and fructose. Okay, and fructose will break down. Sorry, here it will be lactose. I have written fructose. Lactose. So lactose will break down and it will give glucose plus galactose. These three breakdown of these three molecules have been asked several times. That is why I am telling. Maltose will give glucose and glucose. Sucrose will give glucose plus fructose, and lactose will give glucose plus galactose. Then polysaccharides में क्या है? Many units of the monosaccharide is being given on the hydrolysis. Like example में we can write starch, we can write cellulose. इनका जब hydrolysis करते हैं तो hundreds of the monosaccharide units are being given upon the hydrolysis. That is why they are polysaccharides. Any doubt?
No.
Here? Okay. So then we will move to the glucose molecule inside the monosaccharide, which we have to study in detail. That is glucose and fructose. Okay. Here, glucose molecules. See, glucose is first important point that it is most abundant organic compound on Earth. Most abundant organic compound on Earth. What is the formula of glucose?
I thought hydrogen was.
No. Organic compound. It is an organic compound. No? C6H12O6.
Oh.
Yeah. What is the formula? I have already told you. So formula is C6H12O6. Okay. And basically they are found in sweet fruits, or you can find it in honey. Okay. So found in sweet fruits or honey. Fruits or honey. Also, they can occur freely in nature as well as in combined form. We have seen that glucose have several structures. They are found in open state structure, then they are found in cyclic structure, Hayward structure. Many things are there. So they can occur freely in nature as well as they can occur in the combined form. So how they are prepared? Two methods are there. Two preparations methods. First one is तो simple one कि direct polysaccharides जो रहते हैं उनको hydrolyze कर दो. Polysaccharides are basically starch or cellulose. If we are hydrolyzing the starch or the cellulose, then it will ultimately give n numbers of glucose. Okay, the first method is by the hydrolysis. By hydrolysis of sucrose, sorry, starch, not sucrose, is starch or cellulose. Okay, cellulose. So here are the structures already written. How are they prepared? So first one is this one, that they are formed from the sucrose. Okay, yeah, this one. They have been formed from glucose, sucrose. See, line नहीं हो रहा है मुझसे सही. Okay, I will then ultimately use the highlighter. This one and this one. First is from the starch and the second one is from the sucrose or cane sugar. Sucrose से दोनों चीज बनेगा. Sucrose से glucose भी बनेगा and fructose भी बनेगा. So for the preparation of fructose only, this is the reaction, and for the preparation of glucose also, this is the reaction. And second one, glucose को large amount में या industrial amount में अगर बनाना हो, then we use the hydrolysis method of starch or cellulose. And from hydrolyzing them in the presence of dilute H2SO4 or HCl, you can form many large number of glucose. Then reaction. अब reaction के पहले yes.
What's the difference between glucose and fructose?
Okay, glucose has aldehydic group and ketone has ketonic group. Like glucose is having CHO in its compound composition, and the ketone is having fructose is having ketone one, C double bond O. So this is a big difference.
Molecular formula is the same, right?
No, formula is different.
Like in the, can you scroll up?
In the general formula it will fit, okay, but structurally they are different.
Okay, can
अभी
you
हम लोग आगे उसको देखेंगे कैसे स्ट्रक्चर उसका डिफरेंट होता है. मेनली फ्रक्टोज के पास कीटोनिक ग्रुप होता है और ग्लूकोज के पास एल्डिहाइडिक ग्रुप होता है. इसी बेसिस पे उनको डिफरेंशिएट किया जाता है. देन रिएक्शन किसका? ग्लूकोज का. सो व्हाटएवर द रिएक्शन ग्लूकोज इज गिविंग, हर एक रिएक्शन ग्लूकोज की स्ट्रक्चर को एविडेंट करता है कि हाँ ये रिएक्शन हो रहा है तो ग्लूकोज का ऐसा स्ट्रक्चर होगा, ये रिएक्शन हो रहा है तो ग्लूकोज का वैसा स्ट्रक्चर होगा. देयर आर मेनी स्ट्रक्चर्स ऑफ ग्लूकोज. तो एक भी रिएक्शन अगर हो रहा है तो वो देता है, प्रूफ देता है कि हाँ ये रिएक्शन से ग्लूकोज का ये रिएक्शन हो रहा है, ये स्ट्रक्चर निकल के आएगा. सो फर्स्ट वन ग्लूकोज का ये सब तो ग्लूकोनिक एसिड, पहलिंग सॉल्यूशन, ये सब तो बेसिक रिएक्शंस हैं कि ये these are basically indicators. Tollens reagent, पहलिंग सॉल्यूशन, chips base, these are indicators. यहाँ से हम लोग देखते हैं कि फर्स्ट वन इज ये HI के साथ जब भी हम लोग रिएक्ट कराते हैं तो ये जो आयोडाइड या HI के साथ रिएक्ट कर रहा है.
They don't understand Hindi at all.
Okay, sir. Okay. So glucose, whenever glucose is reacting with the hydrogen iodide, okay, it gives a long chain, यानी कि simple chain of N-hexane. There is no any branching, no formation, nothing at all. So that is why this particular reaction suggests that what? That all the 6 carbon atoms are linked in straight chain. They are linked in what? They are linked in straight chains. This particular reaction, the reduction reaction of glucose suggests what? That, just give me a minute. Yes. That all the glucose molecules are arranged in linear chain, means they are in a straight chain and linear one. There is no branching, no sidewise or zigzag formation. They are arranged in linear one. So this particular reaction is the first evidence that this type of structure can be formed of the glucose. Next, second one. Second reaction, like glucose is forming the oxime or it is forming the cyanohydrin. So these two reactions, what they indicate? These two reactions, oxime formation or the cyanohydrin formation, they both reaction indicate that there is presence of some carbonyl group in them, because see, it is replacing what? The carbonyl group only in both the reaction. So these two reactions, that is oxime formation and cyanohydrin formation, these two reactions indicate the structural evidence that the glucose may have the carbonyl group present in them. So I'm going to write also, these two reactions indicate that glucose is having carbonyl group in them. These are all. First, see, we know without any reaction, we will not be able to identify the structure. So first, we do the reaction, and based on the reaction, we only give the structure of the element. So these are the reactions that have been done to find out what the possible structure of glucose can be. So these two reactions has given the idea to the scientist or whosoever has done the experiment that there is presence of carbonyl group in the structure, okay, in the molecule.
Yeah.
Then, yes, any doubt?
No.
Okay. Then the glucose reacting with bromine or mild water. Bromine is what? It is mild oxidizing agent, and glucose reacting with mild oxidizing agent, it forms gluconic acid. Now, if you remember, what do we have our previous knowledge that whenever an alcoholic group is reacting with a mild oxidizing agent, it will form aldehyde. Then further aldehyde is reacting with a mild acid, then it will oxidizing agent basically. It will form what? Saccharic acid, means it will form carboxylic acid. So same way यहाँ पे भी this one is what? It is oxidizing agent, and with what kind of oxidizing agent? It is mild oxidizing agent. Whenever we are reacting the glucose with mild oxidizing agent, it will form gluconic acid, and presence of this reaction indicates that they have an aldehyde group in them. Okay, this reaction indicates what? That they have aldehyde group. Earlier we have seen कि कोई any carbonyl group is present, but what kind of carbonyl group is present, that have not been specified. But due to this reaction, it has been specified here that they have aldehyde group. Aldehyde group. Okay. Then we come to the reaction of this one, acetylation. Whenever we use this glucose molecule in the presence of acetyl group, then it will form glucose pentaacetate. This gives what? That glucose is having hydroxycarbon compounds. Okay, that is presence of 5 alcoholic group, because it will form pentaacetate, and acetate is what? CH3COO, like this one. So acetylation of the glucose gives us the evidence that the glucose structure is having 5 OH group, that is 5 alcoholic group is present. अभी alcoholic group का evidence नहीं आया, but this is reaction. This is giving the basic knowledge that it is having 5 pentahydroxy group. Okay, so this indicates what? This particular reaction. This indicates that glucose is having presence of 5 OH groups. Okay, now the last one. Last one is this one. This one is mild oxidizing agent. This one is what? Strong oxidizing agent. So in the presence of a strong oxidizing agent, they are directly form what? Saccharic acid, that is carboxylic acid. So this reaction indicates that they are having OH group, that is they are having alcoholic group present in them. Okay, so based on the reaction only, the property or the structure of glucose is able to be defined, because there are many kind of structure of glucose. So each and every reaction gives the proper structure of a glucose molecule. Okay? So this indicates presence of OH group in them. Okay. So by each and every reaction, that is chemical reaction of glucose, each and every structure has been clarified. Like glucose is having straight chain reaction, glucose is having carbonyl group, that carbonyl group is aldehyde group, and that they are also having OH group, and that OH group is in 5 poly compound. Okay. Now there is one most important reaction that is basically asked in exam, the formation of osazone. How the osazone is formed? Glucose react with 3 molecules of phenylhydrazine and it will form osazone. This is the reaction which have been asked many times in exam, and it is important one. This one, formation of glucose.
What is osazone?
Osazone is basically one molecule of glucose. When it will react with phenylhydrazine, then it will form osazone or glucosazone. Osazone, you can say, is basically another chemical compound which is having acid nature. Okay, and 3 molecules of phenylhydrazine are required to form this osazone molecule. Okay, then this is basic the chemical nature of glucose has been done. Any doubt till here? What is the glucose? What are the reactions? Okay. Now glucose structural evidence also done. Now what is the real structure? Structure may we can say they have open structure also. Then they have Fischer projection, that is also open structure. Then they have Howard projection also. They have cyclic structure also. So one by one we will see. Okay, where is the, yeah, the second one was what, by sucrose. So what is structure? No? Structure mean they have open structure. Open structure, can you tell me how we will form the open structure? Open chain one, like this. One hydrolyse, it will be open, and then simply going the molecules OH, H, then OH, OH, and then you have the CH2, OH. And the opposite side H, OH, H, and H. Only the difference that on the second, yeah, on this position, third one, not second one. First, second, third one. Third position पे hydrogen का position it's reverse. The position of hydrogen on the third carbon atom is reverse. Otherwise, all the structure are same. Okay, you have to. This one is what, open chain structure or the straight. Now Fisher projection, simple, same like compound is there. Okay, Fisher projection is also what, it is open chain only. Basically, they have done what, this one in fully open kind, and they will be closed here like this one. This is what, same way Fisher projection. Simple. It is very simple to learn. Main difference or main difficulty will come in the learning of the Howard projection, basically. But I will tell you the trick, so you can easily remember that also. Now cyclic structure is what, somewhat like this. Cyclic structure. Cyclic structure will be formed by them. The first carbon atom here and the fifth position's carbon atom here. They will combine with the oxygen, and basically ये दो OH and this H, it will get released in form of water, and they will combine like this. The resultant will be like this. C, then OH, and then H, then OH, again OH, and then CH2OH. 6 carbon को कुछ लेना देना नहीं है. Only the fifth position carbon and first position carbon will be having a work for them. Okay, so they will be forming a cyclic structure like this. This is cyclic structure of glucose. What has been done? The OH group of the fifth position carbon and the H group of the aldehyde have been removed in form of water, and they have formed a cyclic structure. Okay, now Howard projection is like this.
No, can you just tell again? I didn't understand that part. What do you do?
Okay, let me show in a smaller bit. See, what I have done, I have removed the hydrogen of this aldehyde group and OH of this one. Fifth position's carbon OH and the first position's carbon H.
Okay.
They have been joined and they have been removed in form of water, and there is a formation of bond with oxygen in between. So this is how the cyclic structure of glucose has been formed. Okay, basically water remove हो जाता है and then cyclic structure is formed. And then Howard projection, same way you can find out like this. Okay, this one. Basically, their structure is most similar kind pyranose. Pyranose is another chemical element, and their structure is most similar to the pyranose. That is why sometimes glucose structure is also called as glucopyranose. Okay, so I'm going to draw that structure also. This is what pyranose structure, typical pyranose structure. But what we have to do here, we have to draw the glucose structure. So from the right hand side, okay, from the right hand side, we will start labeling like this. And now think of it as a trampoline or something. So on the trampoline, we see many legs. So 1, 2, 3, 4, 5. Okay, 5 legs. Numbering from the right hand side, 1, 2, 3, 4, 5, and 6. 6 will not take part in this one. Chain formation, it will not take part. The sixth position carbon will stay, that I will stay away from all this. Only fifth position carbon has done the work of this Howard projection. Okay, so now we have to see this lower part. Okay, lower part, you can write this right and lower. Right पे lower part. Lower part पे what we have to attach? We basically have to attach OH, then H, then OH. And then here also, same way, fifth position carbon is not here, but we have to attach this one, OH. Upper. Now, we have to see the left side and upper part. So, what are the left? We will write this then. So, this is how we can find, we can form this what? Howard projection of glucose. Simple structure which one formula you have to apply, right lower. Right side of the molecules in the open chain form will be labeled in the lower in the Howard projection form, okay? And the left side of the open chain form will be placed on the upper positions of the Howard projection form, okay? This is how you can easily draw the diagram of Howard projection. It is very similar to the structure of pyranose, and that is why they are also called as glucopyranose, okay? Now, one more thing is there. Sometimes alpha glucose is there, and sometimes beta glucose is written. So why these are being written? Alpha glucose and beta glucose. In this structure only, if on the first carbon hydrogen या OH is on the left side, okay, then it will be called as alpha position, okay. And if this is on the right side or in the upper position, then it will be called as beta glucose, okay. Same, this one is what? Alpha glucose. If I draw this one by changing the positions like this one, then it will be beta glucose, okay. Understood?
Yeah, ma'am. Yeah, ma'am.
Okay. Yes. Then one more thing. We have also seen D glucose and L glucose sometimes have been written. Why D glucose or L glucose is written? D glucose, like this structure. L is basically for fructose. So why this is written D glucose or L glucose? You have seen basically D and L structures. Okay. So D and N structures are just representing their configuration, and the plus here represent the rotation, dextrorotatory positive sign. So if a compound, if a chiral compound like in the open chain, let me draw the open chain first, then I will explain. Okay. Open chain. Yeah. So now we have drawn a D plus glucose. Why are we saying this? If we are taking the lowest carbon atom, which is the chiral asymmetric carbon, and based on this lowest carbon asymmetric carbon atom, we will see that if this compound, that is OH, is on the right hand side, then it will be called as D glucose. Okay, and the positive sign just donate the dextrorotatory nature of the compound. Okay, and this compound OH, OH, H, 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 OH, H, OH, H, and here. Okay. And if this OH is on the left hand side, then it will be called as L glucose. Okay. Any doubt about D glucose, L glucose, or alpha glucose or beta glucose?
No, ma'am.
Okay. So this is completed. Now cyclic structure is also completed. Next, what we have to study, how a projection is completed. Fructose. So same way, fructose is what? Preparation. I have like told you earlier also, fructose is ketonic group. Ketonic group is attached. And what are the preparation? Prepared from sugar, sucrose. Prepared from sucrose. Because on the hydrolysis of sucrose, glucose is also formed and fructose is also formed in equal amounts. So sucrose का hydrolysis पे glucose fructose दोनों मिल जाएंगे. After this, what is the structure of fructose? Same way, we will see only a little bit difference is there in the structure of fructose and glucose. What is the structure? How we will draw the same position like CH2OH. Now we all know that ketonic group can only be attached in the second carbon position. So this one. And then again the same H, OH, OH, and then CH2OH. So this will be formed like fructose, and this is the open chain form. Open chain form of what? Fructose. Any doubt? Here we will write, here we will write D minus sign of fructose. Same way, it is on the right hand side, that is why D, and minus sign, that is it has the capacity to rotate the plane polarized light in the left position, that is why minus sign, levorotatory. Okay, then cyclic structure will be formed like this. Cyclic structure here only, cyclic structure. Same way, this carbon will act the second position carbon with the fifth position's carbon. Means the carbon at the second position will react with the carbon at the fifth position, and they will remove the water, and then they will form the cyclic composition. Okay. Sorry. It will be the first carbon only. Here will how the hydrogen will remove. So hydrogen will remove from the first carbon only. So basically the first and fifth here also in the fructose also, and in the glucose also, the first position and the fifth position carbon will join together and water will be removed, and that's how the cyclic structure will form like this. See, just remove and. Wait, right now it is not a correct one. I'll just make a correct one. OH and OH will be there, then H will be there, and then H will be there, and this will be removed, and they will create a bond in between them, and yeah, that is how the structure, cyclic structure will be formed. Now, Hubbard projections. How Hubbard projection will be formed? Hubbard projection is basically same way. It will resemble the structure of furan. Furan is also a chemical compound. So, furan structure is very similar to the structure of Hubbard projection, fructose. So, that is how we will take the furan structure in mind, and then we will form the Hubbard projection of fructose. Okay, like this only the structure will form. This is what furans. That is why we also say fructofuranose structure, because it has gotten its name from the furan structure. Okay, this one. Oxygen in the center, same way, the same structure will form like this. Now we have to attach the positions. Okay, so 1, 2, 3, 4, and okay. Sorry, I think I have misspelled the position. Just let me draw it first, and then I will go. CH2OH will be there, so it will become first, and then it will become second, and it will be third, fourth, fifth, and here it will be sixth. Okay, so this is CH2OH, and then here it will be H. And same formula we will follow here also. Right one will be in the lower position of this Hubbard projection. So whatever the things lies here in the right side, all the things will be written here in the lower positions, like OH, H, OH, and then H. And whatever are the left, they will be in the upper side. That is left position, upper side. Yeah. So this is how Hubbard projections of fructose is formed. Any doubt?
No, ma'am.
Yes. So glucose is completed. Now we will come to the slide also. Let us see what the slide is saying, because I have gone too far. Yeah, we have completed the reactions. We will see here configuration of mono saccharides, which is given also plus and minus. Minus means it is rotating the plane polarized light in the left position, and plus means rotating the plane polarized light in the right direction. Okay, that is why plus sign and minus sign. Also the DLN, they have no relation with the optical activity. They are just notations. Okay, they indicate relative configuration related to the stereoisomers. Okay, so this is particular structure we have seen. Now cyclic structure of glucose, here also see D-glucose and D-glyceride. By giving the glyceride example, they have basically help us to understand the D-glucose structure. Now cyclic structure of glucose, as I've already told you, that the fifth position's carbon OH group will be removed, and the first position's carbon H will be removed, and then they will hydrolyze, and water will get removed, and then they will form the cyclic structure like this. Okay, so this is the cyclic structure. Here also see fifth position and the first position carbon is getting reduced. Structure glucopyranose and beta D glucopyranose, same way, same was thing. They have taken their structure similar to the pyran. With reference to the pyran structure, they have formed the Hubbard projection of alpha D glucose and beta D glucose. Okay. Now, how to draw Hubbard projection? I have already told you, so this is not much importance. Now fructose is ketohexose because it is having the ketonic group in its position. See, this one is the ketonic group, and this ketonic group represent what? Fructose. Okay. Now fructose open chain structure is this one. Hubbard projection is with reference to the furan structure. That is why it is given at the beginning only. This is the cyclic structure of alpha D fructofuranose and beta D fructofuranose. Same way जैसे glucose का था, in that way only you will write the structure of fructose and the Howard projection of fructose only. Now comparison you can see from this notes when I will share. So there are basically comparison related to tolerance reagent, Molish test, and failing solution. Everything is there. Okay. What are the disaccharides? These are many and huge. So basically disaccharides को तोड़ने पे क्या बनता है? That has been asked as a question. What you can get upon the hydrolysis of a particular disaccharide, like hydrolysis of sucrose, what will be formed? Hydrolysis of lactose, what will be formed? So on hydrolyzing sucrose, we will get glucose plus fructose, glucose plus fructose. Then on hydrolysis of lactose, we will get glucose and galactose. This structure you don't have to remember here, galactose. Then on hydrolysis of maltose, we will get glucose and glucose. Glucose plus glucose. One thing you have to remember here, because two of the glucose join together with the help of this bond, and that bond name is glycosidic linkages, and their position. First carbon position, that is Y1, and the fourth carbon position, they basically their compound get attached and water is removed, and then glycosidic linkages form. Okay, so this is the disaccharides and oligosaccharide part. Yeah, polysaccharide, again nothing will ask from the polysaccharide, only the definition and the examples. So starch and the cellulose are the example of these polysaccharides, and polysaccharides are having large number of monosaccharides in them, and on hydrolysis they also produce large number of monosaccharides. They are large number of glucose, fructose, anything. So they are having amylopectin or amylose. Structure you can see once in some of the exams it can ask, otherwise no, not of much important in board exams. Okay. Now cellulose, glycogen in terms of its abundance. Okay, they are the most abundant carbohydrate in animal body. Okay, plant body cellulose is most abundant part that is stored, and in animal body glycogen is most abundant part. Okay, most abundant carbohydrate. Now summary of this glucose, fructose you can see when I will share the slide. Now coming to the protein part. What is protein? Protein is most abundant molecule of the living system. In the living system, what is in most abundant form? That is protein. And protein they are the polymers of alpha amino acids. Why I am saying alpha amino acids? Because basically the alpha amino acids join together and they form the protein. And there are many amino acids like beta amino acid, gamma amino acid, delta amino acid, depending on the position related to the COOH group. Okay. So if we are taking example, this is basic structure of a particular amino acid, where amino group is also there and where carboxy group is also there. So relative to the position, if the NH2 group is attached to the same carbon where carboxylic group is attached, then it is alpha amino. Okay. If the NH2 group is attached to the side of the carbon of carbon attachment of carboxylic group, then it will be beta amino, because it is getting the second position, then it is getting first position, and it was only first position. Now it is attached with the second carbon of the first attachment of carboxylic acid, then it will form beta amino acid. Same way, third position gamma amino acid, fourth position delta amino acid. So we have to work with our alpha amino acid, otherwise protein will not be formed. So alpha amino acids are joined together in large number and they form the protein. And basically 20 amino acids are there in numbers which are known to the human being till date. Okay, here I am writing 20 amino acids are there. Amino acids are known to humans, are known. And these 20 amino acids are only capable of forming all the proteins in the human body. With slight change in their arrangement, with slight change in their coding, that is how they will form the all the proteins which are present in the living system. Okay. Now amino acids are classified into 3 different parts. What classification is there? Neutral, then basic, and then acidic. By the name only you can say neutral one, equal amount of amino group and carboxylic group. Then basic one, more amino group will be there, NH2 will be more in that compound. Acidic amino acids will be where carboxylic group is more in them. So this is basic 3 definitions you can write by in your own words, like those amino acids which are having more amino group in them, they are called as basic amino acid. Then those amino acids which are having more carboxylic group in them, they are called as acidic amino acid. And those amino acids which are having equal number of amino and carboxylic group in them, they are called as neutral amino acids. Importance is there where we have to write essential and non-essential amino acids. Yeah, are you getting bored, Pratham?
Mhm.
Any doubt to anyone till here?
No, ma'am, I got it.
Okay. So what we have to study here or remember, essential amino acids and non-essential amino acids. Essential amino acids are those amino acids which cannot be formed inside the human body. Okay. So these we have to non-essential is the one here. Essential amino acid basically we have to take in our diet by outside environment, and non-essential amino acid they can be synthesized in the body and we don't have to take it from the outside environment. Either you can remember the non-essential amino acid or the essential amino acid out of these 20 amino acids somewhere or the other. Every time it has been asked in many of the exams. So I have written all the names of essential amino acids in our mnemonics way, like Hill MTV tab. If you will write Hill MTV tab, you will be able to remember all the essential amino acids. When you will be able to remember this essential one, you don't have to remember this non-essential one. Whenever non-essential will come, you will be easily able to say that yeah, this is non-essential one because all the essential one you have remembered already. So this is the formula of you can say mnemonics or the formula of how to remember the essential amino acids. Basically, Hill MTV tab. Hill H is histidine, I isoleucine, leucine, lysine, methionine, tryptophan, valine, threonine, arginine, and phenylalanine. So these are essential amino acids which you have to remember. Okay. Now, some basic properties of amino acids are there, like they are colorless, they are having high melting point, they are crystalline solids, and since they are having both group amino group and all and carboxylic group also, so they mostly behave like salts, as in salt behave, because acid and base together create what? Salt. So their basic behavior is salt. One thing that you have to remember from this protein is that protein molecule, let me write here. Yeah, that they are amphoteric in nature. They are amphoteric. What is the meaning of amphoteric? Yes, they are amphoteric in nature. I'm saying, so what is the meaning of amphoteric?
React with acids and bases.
Yeah, both they have the capacity to act as acid as well as the base because they are having both in them. So they form zwitterion. Okay, zwitterion, and then they will act both as acid also when needed, and they will act as base also when needed. Whenever any protein, just give me a minute. Whenever any protein is hydrolyzed or reacted with water, any protein. For example, we take glycine. I don't have to write so much. So glycine, if we take, this is the structure of glycine, NH2 and COOH. If we hydrolyze or we put this inside the water, so what happens? This hydrogen will get removed, and since both the groups are attached, so this hydrogen will accepted by whom? It will accepted by this one only. So it will form the structure like this, NH3 positive and COO minus negative. This structure is called as zwitterion. Whenever needed, it will act as acid also. Whenever needed, it will act as the base also, because both the things are present. Acid thing is also present, base thing is also present. Okay, so this is the main point of the protein which you have to remember. What is zwitterion? The formation of the protein when they are put in water, they have the capacity to act as acid also, they have the capacity to act as base also. And this particular property or this particular phenomenon of the protein is called as zwitterion formation. Okay, so this is how you can write. Next is we are all the proteins are optically active. Okay, another important point, this one, all the proteins are optically active. Optically active. Exception is there. Exception is what? Again, glycine. See, glycine structure. Asymmetric carbon should have 4 different compounds, but this glycine structure is having uh, This glycine structure is having the same hydrogen. So this is not asymmetric, and that is why they are optically inactive. Otherwise, all the proteins are optically active. Exception is only glycine. What is the linkage between all the protein? Protein linkage is called as peptide bond. Peptide bond. When one protein is attached with another protein, it will called as peptide bond. Basically, what happens? How peptide bond is formed? COH group of one carbon atom and NH2 group of the other carbon atom. CH2, CO2, H. And here we can write CH2 and H2. So they will react. One hydrogen will move and the water is gone, and how this like this the bond will form. Which kind of bond? Peptide bond. This bond is called as peptide bond. Yeah. This bond is peptide bond. Bond between one protein and another protein is called as peptide bond. Now protein is also, I think, finished. Types, we can easily remember dipeptide, tripeptide, tetrapeptide, polypeptide. Depending upon the number of the peptide bond present, we can write dipeptide if three of the protein are joined together. Then if four proteins join together, then we say tripeptide. If five proteins join together, we say tetrapeptide. If a large number of proteins join together, we say polypeptide. Okay. And how we say protein? Because till now we say polypeptide. Protein will be said when number of polypeptide is more than 100. More than 100 amino acids will join together, then we will call it a protein. Okay. And their atomic mass unit should be more than 10,000 km. Okay. Then only we will call a bond between lot of peptides on a lot of amino acids as a protein. Okay. Now classification of the protein. Classification includes globular structure and the fibrous structure. You have to remember globular. Globular itself means something like this. In the ball-like structure, globular protein, and then fibrous protein. Fibrous structure will be somewhat like this. One or the other, they will be arranged in fiber form, serially arranged. One or the other thread, they will coil with one another, and they will coil with the help of van der Waals forces or hydrogen bonding, or many kind of bonds are there which form a fibrous structure of protein.
What is
Straight case of the protein. Yes. This is fibrous structure of the protein, and this is globular structure of the protein. I'm just telling about the classification of protein. One is globular one, other is fibrous one. Okay, based on their how they are arranged. So globular one are basically the ball-like structures of the protein, which are basically the tertiary or quaternary structures, and fibrous one, they are primary or secondary structures. They are joined together by a lot of forces like van der Waals forces, hydrogen bond forces, and peptide bond is also there. So they will form a thread-like structures coiling around each other. Okay, this will be fibrous one. And globular one, there are many forces acting together upon the same molecules. Van der Waals will be there, hydrogen bonding will also be there, peptide bond will be there, and many other forces. Electrostatic bond forces will be there. So that's how the globular structure will be formed. Okay, structurally also same way. Structures will be written. Primary structure is there, primary, then secondary, then tertiary, then quaternary. Quaternary is the most complex one. Tertiary, primary and secondary are the simplest. Primary ones will be like this, the simpler one. Only the molecule will get attached with the simple straight peptide bond. Secondary one, it will be formed of two things like alpha helix and beta pleated. Two type of things are there. And whenever secondary structure of protein is forming, for sure there will be a primary structure, because from the primary one, secondary one is forming, and same way with the tertiary and quaternary one. If quaternary structure is there, then for sure primary, secondary, and tertiary will be there. So how this alpha helix? Its structure will be like this in a helical way. Yeah, like this. And beta pleated sheet will be like this in a form of pleats. Okay, tertiary structures will be more complex structure like this, and quaternary, more complexity will be there. One or the other bond will be joining together, and then they will form the quaternary structure of the protein. So this is how the fourth structure of the protein is formed. Now, one definition is there: denaturation of protein. Denaturation of protein. What is denaturation of protein? Whenever a particular protein which is in a normal position, it is working normally and it is providing all its function. Whenever a normal protein is subjected to any physical change, okay, normal protein, whenever it is getting subjected to any physical change, like increasing the temperature or changing the pH, any physical change, then it will lost all its property. Okay, will lost all its property of normal functioning. Okay, lost all its property, and after losing all its property, it will form what? And will come in the primary structure. In the primary structure, because itself it is still a protein, but it has lost all of its normal functioning property. It will not function as it was functioning earlier due to the physical change, but it will remain in the primary structure. In the primary structure means basically a simple string structure. Primary structure. So the definition becomes what? The change in the property of a normal working protein due to any physical change is called as denaturation of the protein. Okay. Definition is what? The change in property of normal functioning protein.
Ma'am, in 2-3 minutes we can wrap up.
Yes. Okay, sir. Only one more topic is left. Is for okay. Due to any physical change is called as denaturation of the protein. Whenever naturation and whenever the physical change is resumed, it will again start renaturation process and it will again start its own function which it was doing earlier. Now, nucleic acids. Nucleic acids are basically the long chain polymers of nucleotides. Nucleic acids are what? Only this is the last topics. Then enzymes and vitamins, I think only definition is left. Nucleic acids. They are what? Long chain polymers of nucleotides. Nucleic acids are formed of what? 3 things. You have to remember this one. 3 things. One is pentose sugar. Second is nitrogenous base. Nitrogenous base will include 5 things. One is adenine, guanine, cytosine, thymine, and uracil. Okay, 5 things. And phosphoric acid. Phosphoric acid. And here adenine, cytosine, thymine, uracil, and guanine. That's how we can form a nucleic acid, or the structure of nucleic acid you can see like this. One phosphate group will be added here in the slide. So it is given. Let me show you from the slide because it will take time. Where is it? Yeah. So this is hormones, vitamins, nucleic acid. So here is the basic structure. This one is phosphate group, this one is nitrogenous base group, and this is pentose sugar. So this one is pentose sugar, and this is phosphate group, and this is the nitrogenous base. Okay, so this is how a particular nucleic acid is formed. Nucleic acids are of 2 kinds, DNA and RNA, and here is the structure of DNA. In the DNA only, DNA is composed of adenine, thymine, guanine, and cytosine. So every time whenever a DNA is formed, it will always, A will join with T and G will join with C. A will form double bond with the thymine, and adenine will form with double bond with the thymine, and guanine will attach to the cytosine with the triple bond. RNA is what? RNA has uracil instead of thymine. It doesn't have thymine, and RNA is having uracil. So it will join with uracil, and same way guanine will join with the cytosine. This is the slide difference between RNA and DNA, which is given in the slide also. So I think the chapter is completed. Any doubt in the whole chapter? Because only enzyme and vitamins are left. Enzymes are basically what? They are the biocatalyst which increases the rate of reaction in the living molecules. Okay. So in certain enzymes are given, which you have to remember, of course. And vitamins are certain kind of extra nutrients which we have to take from outside environment. Okay. And these vitamins decrease in these vitamins in the body result in some kind of diseases. So vitamin B1, vitamin A, vitamin C, vitamin D, many things are here given in this diagram only. Sorry, in this table only, so you can learn it. Okay. So chapter is completed. Any doubt in the whole chapter?
Ma'am, can you send the notes? This PD.
Yeah, I'll share the notes of this class. Okay.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay then. Bye.
Bye, ma'am. Good night.
Bye. Good night.